Welcome back to the Flex Diet Podcast. I'm your host, Dr. Mike T. Nelson. And on this podcast, we talk about all things to increase muscle mass, which would be hypertrophy for you nerds, performance, and better body comp, all without destroying your health in the process. And today on the program, we've got Dr. Cohen, and we're talking about more on the health aspect related to advancements in longevity, and even as a global topic, I would say regenerative medicine. What things should you be looking for in this area? How do you separate things that can be useful from all of the crazy hype that's out there? Everything from use of other pharmaceuticals, supplements, and different metabolic pathways. So Dr. Cohen is a leader in the field of nutrition, sports performance, and longevity medicine. He did his undergraduate degree in Biomedical Engineering from Duke University and his medical degree from Hahnemann Medical University in Philadelphia, Pennsylvania. So over the past 2 decades, Dr. Rick has used his knowledge to create innovative health and performance protocols and even formulate some nutritional products. And what's also interesting is his wife is a nationally ranked triathlete, and he owns the sports performance, or I'd say more supplement company, Pure Clean Performance. So you can check out all their information there at Pure Clean Performance and check out all of his links there. So big thanks to him for coming on the program and talking to us about everything from blood work to actual true advancements in longevity. And if you're looking for, in my biased opinion, other advancements in longevity that are more related on the performance side and recovery, check out the Physiologic Flexibility Certification. It opens again on Monday, September 5th, 2022. Go to physiologicflexibility.com. So just the idea of metabolic flexibility allows you to alternate between the use of carbohydrates and fat back and forth, and you can upregulate both of those, which is covered in the Flex Diet certification. That'll make you a more robust individual on the side of metabolism and reduce your risk of diseases and increase performance and health. So this is a similar idea, but it's extended up to you as a physiologic organism. So what areas, once you have basic movement and basic nutrition down, will be the next areas you would target? And in the Physiologic Flexibility Certification, those areas are temperature, pH, carbon dioxide, oxygen, and then also fuel systems. So fuel systems, we extend that all the way to carbohydrate loading and then all the way back down to even using a ketogenic approach. If you can upregulate those 4 pillars, in my biased opinion, you will increase your body's ability to recover in record time, become more anti-fragile, and I believe those will lead to also longevity changes. So in the certification, there's everything from cold water immersion protocols. What does the research say on that? There's a lot of good information out there on cold water immersion, and in my biased opinion, there's a lot that is just really utterly horrible. What about temperature? Should you do sauna? Should you exercise in the heat? On the cardiovascular side, when we're looking at changes in pH, this can be done through true high-intensity interval training or other directions via long, slow distance training. How do you know when to do each one? As we mentioned, everything from a ketogenic to a carbohydrate approach. And then we get into, let's say, more of an advanced area looking at carbon dioxide and oxygen. How is this related to your breathing patterns? Should you be doing nasal breathing? Should you be doing mouth breathing? How do you know when to do each one? Should you be doing a Wim Hof type practice in the morning? What type of breathing work is best for meditation, exercise, performance, and recovery? So check out physiologicflexibility.com for all the information. The PhysFlex Cert opens again, as I said, Monday, September 5th, 2022. It'll be open for 1 week until September 12th, 2022. If you're listening to this outside of that time frame, you can still go to the same link, physiologicflexibility.com. There'll be a wait list there where you can get onto the wait list. So if you're listening to this before it's open, hop on there, get onto the wait list. That'll put you on the newsletter, and you'll also get the opportunity to enroll and get some cool free bonus items too. So go to physiologicflexibility.com and enjoy this interview with Dr. Rick Cohen. Welcome back to the Flex Diet Podcast. I'm here with Dr. Rick. How's it going, man?
Good. Awesome.
Yeah.
You're from cloudy Western North. Yeah, go ahead.
Oh, you said where are you from?
Oh, cloudy Western North Carolina in the Blue Ridge Mountains.
Oh, nice. I just talked to a guy from Raleigh, North Carolina the other day, Sam Miller.
Okay.
So he was just on here.
Okay. Yeah, we're small town south of Asheville.
Oh, okay. Oh,
Super
very nice.
Green. Yeah.
What is it?
Super green and rainy.
Okay.
Yeah, and you're up at about 2,500 feet, so it moderates the temperature as well. It's a unique little area.
Nice. Very cool.
Yeah.
And today we're talking about, shall we say, real life longevity and health. And this will be tied into, obviously, on the fitness side. And then when we started, you said you had kind of a philosophical aha. Do you want to go into a little bit more details on that?
I think the first place to start for people philosophically is, what if we could live healthfully and have a long health span to 150? Like, how would that change your day-to-day? Mike, you're doing this. What would you do differently? What other opportunities might you endeavor? Because we look at our lifespan, it's divided into different phases of life. So we tend to think that these phases of life are just what you do. You're young, you grew up, you got a little smarter, you got married, you had kids, you raised your kids, and then you did your own thing, and then you get old and you die. And hopefully you don't get old too soon, that health span, or get diseased. And in our country, that happens way sooner than later. Here's one paradigm aha, and I hope there's a couple aha moments from this podcast. Our discussion is that phases of life are programmed. Okay, they're programmed across the mammalian species. If you go from humans to whales to other animals, the puberty to reproduction to decrease in function is a clock that's set in. And that's a new revelation in the world of longevity. There's a programmed mechanism that exists, which is different than amphibians and reptiles, which is like, oh, it's like lobsters really don't get old. Crocodiles they're just as virile. Rockfish can live to 150. So there's something about this thrifty gene that over the years and millennia, evolution said, you mammals, since you can't fly very far, or since you can't swim across the world, you live in one particular location. And it's going to be more beneficial for you as a species to die individually to save your gene, because genetics allow the survival of the fittest. And some people might dispute that per se, but in essence, the more you can pass that genes, the more people are turning over, the greater the opportunity is for that species to be fitter and continue. And there's scientists doing everything. There's people who modeled this out, and they modeled out what happens if X people die over a certain amount of time versus if they live longer. And there was a competition between the two. And basically it makes sense if you're not able to get away from threats, that it's better to knock off each individual person. So yeah, the second aha that comes with that, do you hear me?
Yep, I can hear you just fine.
Okay, I'm getting us some feedback. Okay, the second is, if that is programmed, okay, then it can be hacked. So if nature has figured out, and it's complicated, but they're starting to break away at that program. They're starting to begin to understand we can reset. And think of a computer. It's like we used to use the car and the wear and tear. So the current, or the theory, and it's moving to this direction, is we wear and tear and get old, right? And so that's the analogy. That's not really it, because we know we can reset a cell. They've done that. And there's certain things called Yamanaka factors And they can actually go in and change these factors and reset or partially reprogram the cell to become younger again. And they're doing it in a whole variety of different ways. So if we're getting back to the computers, okay, you have a computer and it gets bugs and it gets malware and it gets viruses and it gets registered issues. And you can throw on your AVG and your Norton and you can keep it going. But eventually, it's just never going to be what it was when it's younger. So the only way to really get that hardware back is to wipe it out. But you don't want to wipe the whole thing out. You don't want to wipe out your program. You don't want to wipe out the operating systems because you're not going to know what to do with it. So with the body, can we figure out a way to partially reprogram and reset the cells? And we know we can do that, which is like phenomenal. So it just changes the whole paradigm of we can reset a clock. We can't do it efficiently, but there's indication that that may happen, which is really cool. So that's a big aha, and it changes what you might be able to think of as possible.
So is part of that related to like the telomeres and the theoretical limit that it's 120 years, I think, but then some of the other studies looking at telomerase and other factors show that the old analogy I used to hear is it was like the end of your shoelace where it just degrades so much. And then what was it, the Hayflick limit, like you're limited to how much time that cell can reproduce, but then they realize that's not really true, that maybe you can reverse that process even. So maybe this theoretical limit from that isn't as much of a limit as we once suspected.
Yeah, and it's like a way to, we could get 10 different scientists talking about different concepts.
And they're all going to say what they're researching.
They're all going to say what their research is and what their bias is and for right or wrong, if that's the case. But here's the key point is we've been too stuck in the weeds, right? We're too stuck in all the particulars of that detail. And how can we fix A and B and C and D? But maybe we can, if you remember, this is just a very broad reach, but there was a show called the IT Crowd, and it was like when they had a computer program, did you turn it on and off? So maybe all we really need to do is reset. And so while telomeres are a marker or sort of a surrogate marker of perhaps stem cell population, which could be there seem to be linked together, it may not be a direct cause of the degradation. It's a marker of the degradation, and it's maybe a timeline of the degradation of that cell or the diminished function. But is it in and of itself? And yeah, can we make that longer? Could we help certain immune senescent cells? Could we improve things somewhat? But that's not the cause, right? That's not what we're finding out to be one of the pieces of the cause.
So what would you hypothesize that is the cause or causes?
Gosh, there's some clock, and there's a researcher is a scientist, Harold Katcher, and I should have remembered his book. And he has come across certain blood factors, or he called them chronokines. And there are particular plasma, maybe proteins or peptides that seem to do signaling. Now, when you're younger, and they seem to be in a high concentration when we're very young, what triggers these is unknown. But what they've done is they've actually isolated out some of these factors, and they've been doing some mouse studies, and they've seen some very significant improvements. Like they have the strongest significant improvement. They're still pending lifespan studies, but so we know that there's some factors in the blood that are being controlled from somewhere. And how many different levers need to be pulled to make this control? So we know that there's studies with parabiosis. You're familiar with that?
Yep. Explain to listeners what it is.
So parabiosis is a term where they've actually taken two animals, typically rats, and they've tied together their blood circulation. And within this process, the young rat gets some of the old components of the older rat's blood, where the old rat gets the younger components of the young blood. And they see degeneration in the young blood, with the young mouse, and they see regeneration in the old mouse. Now, it's not a perfect scenario. And there's a few studies that sort of have come up questioning, and then there's debates on, is it young factors or is it just the diminishing of old factors or senescent cells? Are we removing certain things? And it's probably a bit of both that's going on, but that's the parabiosis. So there are particular peptides. So there's a peptide called GDF11, which is a very strong rejuvenating stem cell peptide. And there's a company called Elevion, which is trying to use this natural peptide, come up with a variation of their own and use it as a disease treatment for post-stroke, which is a problem in the research. The general research is getting something approved just for aging. Our Western model, which is another thing we can spin off to here, but our Western model of medicine is disease oriented. It's what's your what's your ICD-10 code, which then the insurance company will cover. It's crazy. There's been some good studies, go off in tangents here every once in a while, but with rapamycin, we can talk about that. They've actually shown rapamycin in mice can regenerate bone for periodontal disease. Okay. So nothing's really been able to show that. And they're going to further this concept that studies happening at University of Washington. They went out to get funding for this, and the venture capitalist says insurance is not going to cover this. They're not going to cover for periodontal treatment for oral care. So we don't want to back it. So now we have this financial incentives, which are influencing science or which direction we go, which is silly. Having said that, with all the people with periodontal disease, I think if you come up with a fairly inexpensive treatment, I think people would pay for that. Where things head, unfortunately. I'm sorry, where were we before that?
I think rapamycin can't really be patented anymore either, unless you tweak the molecule enough to say that it's a new invention to file any IP on it. So you've got what's a financial incentive too, which is the issue with old drugs and even peptides and other things that aren't patentable. It's like they may have a lot of new applications and other uses. Granted, they could be used off label, but for new indications, who's going to fund that research then?
Correct. And unfortunately with rapamycin, and that's a whole longer discussion, and remember where we were before with disease orientation, but with rapamycin, there's enough interest in it. It is probably the number one molecule. If we look at all the different ways that we can help slow down the aging process or extend our health span, rapamycin is probably the most well-studied across multiple organisms, 84 different touch points that have existed. It addresses a mechanism that's been around single cellular organisms. So this is something that crosses all species lines, from bacteria to multicellular organisms. There is interest in it, and there's crowdfunding. There's DAOs that are being started, and so that's happening. And there's even companies that are self-funding particular projects. So that's exciting, but it gets into the second aha for me is studies, right? And it's things that you read a study, and even scientists, right? How many people can sit and read that whole study and then analyze the data sets and really figure exactly what's going on? It takes a good amount of time to do that. If you take a medication, so let's use rapamycin, and there's some studies that are right now with IND, and there's one that I was going to partake in, but I'm like, I think it's going to have some issues. If you take, because they're just taking people randomly, and they're putting into subsets, and they're saying group A gets a placebo, group B gets X milligrams, and group C gets double X milligrams. And what we've created a situation is we're not relying on each person's individual biochemistry. Maybe I need, just based on my absorptive capabilities, a higher dose, or maybe my dosing to optimize or reduce the potential adverse effects needs to be a little different. Because the effect of rapamycin relies on a peak of the concentration that you're absorbing it, and then how long you can stay in the trough, so you can reset some of the things that are being suppressed, and that's the way you avoid having any issues. But if we randomly just give it to people without knowing what their individual needs, some people we're going to get right, some people we're going to be less than optimal, and some people might have some issues because we just got them completely wrong because we had to put them in subgroups. and we really couldn't individualize what was best for each person. So if you take any study, and what they're going to wind up doing is, okay, we have a 20% improvement, maybe, but that doesn't say. The second part is maybe of the group you're studying, 50%, if you pick a metric, you could pick a fitness metric, right? 50% were able to lift 300 pounds and 50% couldn't do more than 100. And maybe they all started at 100 and we average it together and we say, oh, it was a 50% improvement. So we've taken that metrics where to the 50% it worked, it was amazing. But to the 50% it didn't do squat. But without knowing the data and without knowing beforehand, are you as a coach or a professional going to say the same thing for every person? But that's what we do with medications. It's like the study said it's good enough to get approved. And now everyone's going to get it, even though we know even though the researchers know or the company knows it's not going to work for half the people at all. It worked really well. So that's a problem when you do larger studies. And the other problem is relative benefit, right? So when you look at studies, it's like, what's the relative benefit? And you'll hear things, 200% improvement or 50% reduced risk of, and this happened actually with my sister, who had a very non-invasive breast cancer issue. And they were saying, hey, you want to take this hormone and it's going to decrease your risk from 8% to 7% or 6%. It's like, okay, that it's good. Well, no, he initially said to her, this was it. He initially said it's going to reduce your risk 30%. I'm like, okay, what's your actual risk? It was 8% to 6%. And what's your side effects? Right. So you're getting her a 2% chance that it may or may not come back, not even taking into account her age, not even taking into account she was going to change her nutrition and all these other factors that would make a big difference. They were just throwing her into any age group and saying, this is the changes. That's not relevant to her. And you hear studies where, hey, that's a 300% increase of heart disease when you're eating this particular food. Maybe your chance was 1 in 100 before, and now it's 3 in 100. Are you really going to change your whole life based on an epidemiological study that 300%? Oh my God, that sounds really bad, but it's not. It's meaningless. And yet people will do that maybe with a statin. It might increase your risk, decrease your risk. But what was your risk originally based on all these factors? So getting back to my point, studies are good, but they're really confounding and they can guide you. But ultimately, if you're going to work with someone, you need to figure out what that person's needs from a functional point of view, what their weak links are. And that all fits into understanding how to address aging, which to me is like the third big haha is Western. We were talking about Western medicine addresses disease. Most disease, especially the large preponderance, is underneath the aging umbrella, right? So we play whack-a-mole medicine. Maybe this one, we can magically get rid of cancer in this country, just one of these medications completely worked and cancer didn't exist, what do we do to the lifespan in our population? How much does it change?
Yeah, I'm not really sure on that.
Billions and billions of dollars are spent. 4 years. 4 years. That's all we changed because you've stopped cancer, but now what gets you? It's
heart disease,
or it's stroke, or it's Alzheimer's, or it's a pneumonia, or it's immune senescence, or it's a hip fall, or it's a sarcopenia, or whatever. So it's a whack-a-mole. Well, we're going to give you medicine for this, we're going to give you medicine for that, we give you medicine for that. None of them really are stopping it. You're just buying a longer disease span within it. So, oh my gosh, so all this really makes 4 years. So we need to address age. That's what we need to, because all these problems, yeah, sure, you can get an issue. People can feel unhealthy or they may be sick with other chronic diseases, but autoimmune issues. But the things that kill us are all under that aging umbrella. And you hear died of old age. That really doesn't exist. It's just a person who dies of old age. It either wasn't diagnosed for the most part, or it was an underlying cause. But ultimately, one of those things get us. And the more we can build a resilience for the body to fight off or to not allow those things to happen, the more time we can have until we figure out how to push that on-off reset button. And And that's where rapamycin comes in, per se. And that's where a lot of the lifestyle or dietary patterns also can play a big role. So hopefully those are three.
Yeah, no, that's good.
Yeah.
I always think of one of my favorite phrases, and I don't know if I stole this from Sean Casey or who I stole it from, is that kind of research points the way, but me search gives you the answer, meaning you as an individual. So I always think about that in terms of coaching people. If coaches, trainers can be up to date on the research, they have the skill set to read it, or they're taking information from people who do, if they don't have that skill set and they're working on it, then that's still good, because that's going to definitely limit you into don't go this way, go more this way. But as you said, research is always going to be generally comprised of averages. And even within that, if you fit the demographic of it, there's huge, sometimes, disparity, heterogeneity in the actual data itself. So especially when I do peer reviews, some journals have tried to do this, but forcing people to put in all of the raw data, or at least put it in a supplemental file. And then you can look at that and see, even with training studies, you'll see this sometimes. I think Stu Phillips did one with 12-week training study. Most of the people were in the middle. 2 people were way up here. And then one poor bastard actually lost muscle and got weaker. You could argue that maybe for that person, maybe there was some other uncontrolled factor, like sleep has been proposed as one, other things, but maybe it wasn't the right protocol for that particular person either. It still moves the conversation forward, which is great. But I think sometimes people expect that one single study is going to give them the answer as an individual. And again, that's rarely ever going to happen, because usually you don't fit the demographic. You're always extrapolating and trying to figure out what is the consensus of the research, and then translate that, especially if you work one-on-one with people, to, yeah, all the research kind of says this direction. I think we're going to go here. My experience shows me this. So like when I set up a program, I think, okay, let's go this direction. I think that'll work. But if it doesn't, or it doesn't get the result that I want, I try to set it up in a way that it gives me information so that the next step I do is going to be a little bit more accurate. So you're still doing an iterative process, but you're trying to reduce the number of iterative steps that you can make, because the person's paying you for a result, and they're paying you to get that result, hopefully safely and in less time.
Correct. It's a roadmap. You're starting off in a particular direction. You're heading east. Maybe you don't know exactly every road you're going to take, but you're going in that direction. And you would never sort of start off on any journey not knowing where you want to get to.
Yeah. And so if we scale up and look at different, like a 50,000 foot view, what are some things people can do? Obviously there's nutrition, exercise, sleep, things of that nature. How do you think about that, and how do you prioritize what would be closer to the top than the bottom? Because everywhere on the internet now, everybody seems to have one particular single factor that's going to solve everything. And one thing we've learned from physiology is that it's multifactorial, redundant, anisotropic, it's not linear. And this is all based off of the research we have, which maybe 30, 40, 50% of it may be shown to be incorrect later on, and with a very fuzzy, incomplete picture at best.
Correct. So there's two key points before starting off with that. One is you need to track. And it's hard for people. I don't know what it is, but it's just easier to take something. It's easier, as you said, here's your magic solution. Even though they've tried that magic solution 20 times before, it never works, but it's still easier to take a magic solution. But if you're going to go out on that journey and make a commitment, let's say in our case here, make our commitment to begin the process to invest in a healthy, longer life, because that's what you're doing. You're investing some time, some energy, hopefully with guidance, so you can not be sick. So you can be doing what you love to do. Or Peter Attia, sort of physician in New York, is well-known educators, like, how are you going to do your centennial decathlon? Can you still be doing the things you love to do physically? I'm like, how old do you want to be still doing kite surfing, right? Yeah, be 90. Why not? You have to be fear of injury then, but maybe, right? Maybe if you keep on balance and keep on strength and So it's understanding what you need to get there and what are the tools, what are the markers that you need to monitor, and probably past what we want to discuss now. But there are certain key inflammatory markers, glucose markers, toxic markers that you want to address, because there's always a weak link. And I see that a lot on some of the forums. And you have guys who are doing one or two things, and then they may be taking 73 different supplements. And I kid you not, this happened last week. Someone who was actually doing a consensus opinion on all these different supplements, all these different, we'll call them molecules, because whether it's a pharmacological molecule such as rapamycin, which is really just a natural molecule, and it's ultimately no different than resveratrol, which is a natural molecule. It's just one was registered, approved, and has a smaller, not safety, but it has a stronger effect per se than another one would. So 80 different supplements, literally, it was taking a day, maybe more. Like it was like 80 different, but pills, maybe over 100. He was questioning about whether he should take this particular new diabetic medication to reduce average glucose, because he was pre-diabetic, or was getting into a diabetic situation. I'm like, what? So here he was, someone who was doing all these things and hadn't addressed core foundational is get your metabolism, be metabolically flexible, and understand that. And before you do anything else, make sure what you're eating, how you're moving, how you're sleeping play a role into metabolism. So a lot of times we put the cart before the horse, because it was a lot easier to take 80 pills for him than to actually make this core change. So having those metrics and finding a weak link, whether it's toxin or whether it's, we see that sleep or it's excessive stress, whatever it might be, each person has a weak link. And whether it's a familial genetic / epigenetic risk, if you overlook that because you don't want to pay attention to it, that may be the piece that gets you, no matter how well you do on everything else. So I think that's the second, those 2 points are overlooked within it. And then you could say, okay, what's important? And I would say physical activity. I would start with that, being metabolically, physically strong, balanced, strength, endurance, or having a broad range of fitness across is super powerful. And that's one of the things that you can begin to expand on. And you could break that down too. You have people who just do one part of that, and they don't pay attention, or they're moving weights in the wrong way, and they're picking up bad muscle patterns that they're going to get injured. And once you get injured really bad, then it's sometimes really hard to get over that. So expanding out that fitness model in a way and doing some tracking with that is I was even thinking, boy, how cool it would be like to have like a life fitness gym, right? Where you actually come in and break down different modalities. And if someone would look at your movement patterns, and you could evaluate what maybe your aerobic threshold is, and maybe you need to be doing more of this and less of that, whether it's zone 2 or you're not doing anything high intensity. So those are pretty powerful tweaks that we can make to improve how we feel. Is that going to get us to live longer? No, but is it going to increase our health span? But if you're not doing that, it's really hard for anything else. You just sit on the couch and try and take rapamycin, you're not going to get your bang for your buck there. So I would say that's my number one. Could probably put it in with number 2. I don't know. I think the number 2 thing probably that affects us is sleep. It would be not getting adequate sleep, because that just affects stress levels, metabolic. Again, it's feeding into those 2 together, feeding into the same pathways, making sure you're getting adequate deep sleep and also REM sleep. And there's tools that you can use. It's another challenge is if you do labs and use devices, is you always can't rely on them. Some of them are better than others. Some of them give you more information to determine that. And I guess I would go third with some type of calorie restrictive eating pattern. Even that would be my third. So whether it's some intermittent fasting, whether it's some periodic fasting mimicking, sort of calorie restriction, doing it on a regular basis is just not obtainable. But the closer we can to resetting the body. And you have to think of this is where rapamycin is sort of calorie restriction in a pill. It's letting the body or not continually stimulating mTOR and let AMPK and autophagy take its place. And I don't know if you've discussed that before.
Yeah, explain the difference for the listeners.
Yeah, so we'll keep it really simple, but it's like mTOR is an enzyme that is an energy signaling molecule. And when we have enough calories, it tells the body to grow. It's an anabolic signal. And the problem is if you continually keep that signal, it's almost, let's go to analogy, it's your gas pedal and you're pushing your gas on the car. And AMPK balances. That's when you're in a calorie deprivation. And if we looked how man evolved, we didn't eat 24 hours a day. We probably ate 4 hours a day, 4 or 5 hours a day. So within that time of non-calorie consumption, AMPK was an energy conservation and signals something called autophagy. It gave the body time to clean up proteins or waste products and so forth. If we're continually triggering mTOR, you get bigger people. Look at baseball players. Look at the size of people now compared to 30 years ago. They're way bigger. The problem is if the cells, once you get into your late 20s, the cells don't need to grow anymore. And that same trigger that causes something called hyperfunction in the cells, and that hyperfunction leads to all of the age-related diseases, and the cell can slip into a sort of gerosenescence mode where it starts to use inflammatory cytokines and so forth. So there's therapies that exist now to try and remove these senescent cells, and whether it's medication, fasting, et cetera, but better we not let them develop to begin with. And by modulating food, not eating all day, periodic times off, you're going to reduce that mTOR trigger, and using some mTOR sort of synergistic rapamycin, that's where that can do that even more. That's a really powerful way to think. It's this on-off switch for the body, and it needs to be off. And if we're continually triggering it, and you can see it's like we don't spend time with that as much as we spend time more with the type of foods we eat. And I eat vegan, I eat protein, I eat less. And yeah, I can go down that road, and I'm sure you can too. And I did cringe on your cold cereal breakfast. I'm like, no, I could never do that. But yeah, it's like, how much is that really? I get what you're saying. If you're doing most things, how much is that really playing a difference? Now, there are some foods, crap foods and crap oils and high seed oils is a big no-no, and that sets up things metabolically. But some of the fine tuning, unless we have some personal GI needs, is we're arguing over fine points, because the big points are some of the ones we've already discussed: movement, sleep, turning off mTOR, and getting light. That's another one overlooked. Getting sun. We need sun. And if you're not getting sun, you're not creating mitochondrial melatonin. You're not creating vitamin D. And oral vitamin D is not the same as the sun. We always can't get it. We can't be living somewhere where it's Southern California, 10 months where you can get that all year long. So there's ways around that using light banks, red lights and UVB lights, which are a better way than just taking supplements. So some of these foundational things that we can do are really powerful. They just take a commitment and someone to educate you how to incorporate that into your lifestyle. And what are you willing to do? Is it a little bit extra time? And ultimately, I think for people, it's feeling better initially, unless you're like me and a lot of other sort of very dedicated. This is, for me, as a puzzle. It's a passion. It's like, how can I do this? It's my background. I might as well go down the rabbit hole with it. And I would say the other sort of simple, inexpensive thing is how we breathe, or how we handle stress, using HRV, right? Using HRV and some of the maybe coming biofeedback to understand how we can breathe in a particular way, whether it's resonance breathing or nasal breathing, which are extremely powerful. If people haven't read the book Breathe, I'm sure you have, by James Nestor.
Yeah, James Nestor's been on the podcast here, so they can find that episode.
Yeah,
I liked it. I thought it was very good.
Amazing book. And his sleep studies, right, where that was super impressive. So just he and I don't remember the gentleman he went in with, but a breathing expert, they did 2 sleep studies. First one was they clogged their nose. They actually put plugs in their nose and they lived in a sleep lab and they ate, they exercised, they did everything normally would do. And after this period of time, their sleep caved, their blood sugar went up, their aerobic capacity went down. So everything that you would see with getting ill just by plugging their nose. And then they flipped it and they went back to nasal breathing. Everything returned back to normal. That's incredible to be able to do. So put tape over your mouth, right? At night, focus to how you're breathing while you're doing a workout. Huge stuff. It's just, we're not educating people. And I think there's so much information out there that these core, I'll call them tenets, right? And there's others, right? Passion and community and so forth. But these real core tenets of foundational health get lost because they're not sexy. I can't pay $200 for this supplement that look what might happen to me. And it's a shame, but those are some of the huge, and we're gone through a list, like hormesis is another, right? Challenging the body, whether it's a fast or cold or heat, or I've been playing around with hypoxic hyperoxia, which is really cool.
Live O2 system or
live
different
O2,
system? Yeah.
The live O2, yeah. So it's EWAT with hypoxia. Hypoxia, turns out, is an mTOR trigger. Right. It's another way to, not mTOR trigger, it's another way to suppress mTOR. So it's a challenge, it's a hormetic challenge on the body. And the idea, if anyone's not familiar with this, is there was, by putting the body into a hypoxic situation, you create vasodilation, you get nitric oxide release, and the body is craving oxygen. And then you flip the switch immediately, and you get this big flush of 90% oxygen getting into tissues that would have never made it otherwise. And that has a powerful sort of VEGF for capillary formation, for cellular mitochondrial biogenesis. There's even suggestion that stimulates histone demethylation. There's a genetic, and histone demethylation is a way to change epigenetic coding in the body. And there's a particular, and I haven't gone down the full educational pathway on this, but there's a protein called JMJD3, which seems to control this histone demethylation across the board. So you get these histones that are wrapped up, and they're able to change the particular methylation sites all at once. There's so many of them. So the body has a way to coordinate that change. So that it's playing a role in that as well, which is pretty cool. Yeah, I was running. Takes a little time. I've only doing it a couple of weeks with a PO2 of 50 or so for 5 minutes. It's a little hard. First time I went up to 22,000 feet and I couldn't last for more than a couple of minutes. So I dropped it down to 17. But when that oxygen hits you, it's really, you just get this flood, and we'll see. I'm interested to see how it affects some of our fitness metrics, and you can use it as well in a slightly different way for performance training. So Jackie, which we tried to get her on the other day, but I didn't. Be careful with your wife when you're doing new tools.
Yeah, my wife's used to all my wacky experiments.
Yeah, I didn't completely explain to her that how short of oxygen she might get with that. So she was feeling comfortable with it, but you can lower the oxygen. But if you want to train at high altitude, and then you can just periodically pulse the oxygen through. So that's a cool device to consider as well.
Yeah, I'd be interested in the performance increases on that, because not my theory, but a theory I had for a while was that if you look at altitude training, right? So altitude training for athletes for performance has flip-flopped back and forth multiple times, right? The old school thing was, hey, go train at altitude because it's going to be more difficult. You have less oxygen, you have a less partial pressure of O2, and you'll get these metabolic benefits because of it. And there is some truth to that, right? So if you deprive oxygen, you do see increases in red blood cell mass and EPO and all these other factors. And then later on, they said, oh, no, that's not a good thing to do, because you do get some of those adaptations, but the quality and the amount of work you can do becomes severely impaired because you literally have less partial pressure of oxygen. So some of the newer studies have said that you should sleep at a higher altitude to try to get those kind of positive biochemical adaptations, and that you paradoxically should train at a lower altitude because you can get a higher quality of work. And a couple of years ago, probably a year ago, I looked at, is there any really like placebo-controlled randomized trials of that? Because if you move altitude, people generally know. And the hard part is if you have a less partial pressure of oxygen, if you've ever done that, almost immediately what group you're in too. And
oh my God, you just see your heart rate go from
flipped back and forth. And the number of like really good studies on it is actually, I was disappointed. It was a lot less than I thought there was going to be.
Yeah, my take, and that's a question for, and there's some professionals and cyclists that are using this with the particular unit that I have. I would say if you could train your body, whether it's sleep or it's just do 15 or 20 minutes to get that effect, get the hyperoxic signaling effect, and then go do your normal activity. Someone may differ, right? Because now you've supercharged the cell, you've been oxygenated, and you can go harder. Because when you're using that, I have a pulse ox and it lags. You don't need a pulse ox other than at a steady state to say, how low am I? But you're riding, let's say I'm just 80 watts. I'm spinning at 70 or just 80 watts and my heart rate's 110. Within a minute and a half at 17,000 feet, I could just see the heart rate trend up to about 134 and you start to feel it in your legs. So there's no way you hide that. And then you hold it out for 4 or 5 minutes and then you turn on the oxygen, take some deep breaths, and then heart rate just drops right back down within 30 seconds. It comes back down. So clearly that's having an effect in some way. And if that in and of itself should create that same red cell EPO benefit in a shorter period of time. So now you can go out and do the work. Now, if you're training to be at altitude, that's a different story, right? If you're going to go,
then it's simulation training.
Then it's simulation training, exactly, right. As opposed to powering. I would say you need to, somehow you need to do both, because that's true. Because you can't. I'm toying around. I'm doing a rehit today, and
what is that
benefit? Oh, I have a Carol bike.
Oh, okay.
Yeah, it's cool. I love the bike because just for the rehit hard, but just the bike and just the precision of setting watts and heart rate, it's nice. For those, from a Carol bike is an AI driven wind gate principle where you warm up for 3 minutes, go 20 seconds all out, rest for 3 minutes, and go 20 seconds all out. Recover, you're done. You're sucking egg after that 20 seconds.
Brutal. We used to do it in the lab and we'd take bets to see how many people would throw up.
Yeah. The cool thing is about the bike is it gauges your heart rate recovery between each cycle, and it's figuring out your power and it's ramping up the resistance at the end to keep you pushing as hard as you can. I can hit maybe 1,000 watts for the first 5-6 seconds. And can I hold it to 650? I think that's the highest over 20 seconds. And then it'll adjust that for the next activity. And it gives you a score based on your recovery and wattage and your total wattage that you put out. So the question was, my son and I were chatting yesterday, is should I do a adaptive EWAT before? Do I do that and then do the rehit? Or maybe do I just do 3 minutes of like oxygen breathing, do the Carol bike just as primed, and then just do, the 15-minute adaptive just for its longer training effect? I don't know. I'm guessing that I'll get a better score if I do the rehit first, because it is some fatiguing afterwards per se. So don't know.
Yeah. My model I use for the Flex Diet Cert and the Phys Flex Cert is a model of eustress and distress. So distress is stress that takes you much longer to recover from. Eustress, eustress is stress that you can generally recover from a little bit faster. So if I was doing a lifting protocol and I was doing a eustress model, go to the gym Monday, do some stuff, maybe take Tuesday off, do cardio, and then come back to the gym again on Wednesday. From a lifting model, a distress session would be if you have a competition, right? So then it's performance is the only thing that really matters. And if I have to take a week off after it, it doesn't matter. It's the same thing with endurance. Can you see general performance increases with each endurance session? But if you have an Ironman, you've got a big race, who cares if it takes you 5 days to recover, unless you're doing some crazy multiple type race type thing. And then within that, I would subdivide like a eustress would be like an in-season model where your goal is performance is the number one thing, because if you're working with a professional team like NHL hockey, baseball, they have so many games, they have to perform high, but then they have to come back and do it again. And then the off season, you could play with a distress model for 2 to 6 weeks. So if you look at some of the stuff on, say, carbohydrate depletion before higher intensity exercise, your performance is obviously not going to be as good because you're purposely withholding the main substrate you're using. But there's some super interesting studies showing that the molecular adaptations from that may actually be, or they are, greater than the normal training you would have done. So if you've hit a maximal point, maybe you need some of those higher molecular adaptations, even though acutely your performance is going to be a little bit worse.
Correct.
And then when you flip back to a eustress model, hopefully in theory, and the studies right now, at least for carbohydrate stuff, are like almost split 50-50, that you may see a better increase now because now you've got the higher molecular changes, and then you're going back to more of a performance-based model.
Where the Sapiens and their CGM sort of guidance is, you definitely can perform at a higher level with a higher glucose than you can perform if you're going in ketosis, or you're going in low carb. I suppose if you go really long, that's okay. But if someone's going to cycle hard for a couple hours, not going to happen. They're just not going to perform as well. So what you're saying is, if someone's in season, adjust accordingly so they can fuel themselves, but then off season, cut back and cycle off and really train the body, stress the body in some ways. So that makes sense.
Yeah. And I think in theory, you can apply the same thing to oxygen. So my guess would be doing a hypoxic type session on its own, or maybe a block of it for a week, knowing that your performance may actually degrade a little bit because it's obviously going to be much harder. You're not providing oxygen. But then when you go back to a eustress type session, do those molecular adaptations that you got, are they then offset by a higher level of performance? So like the keto people have often argued this, that if you're doing long endurance training, that you need this super long period of keto adaptation, and then ketosis would be superior. The hard part is most research doesn't match that, and that the time that you would need to do that, they argue, is maybe 6 months, 12 months, 16 months. It's a very long, protracted period of time. The downside with that is that you may be performing lower for a year and a half, or to me, it's, man, that better be one hell of an adaptation at the end. But if you've got some like oxygen or carbohydrates where you've got more of an acute change where performance does drop, but it's very acute, you don't have to give up 6 months, then I think it allows you a little bit more flexibility to play around with different things.
Yeah, as you're speaking, I think with oxygen especially, and there's some protocols using altitude sort of cylinders that actually block oxygen uptake. It doesn't have the hyperoxic oxygen flood, which is a big benefit. But what they found is your adaptations are even at 3 weeks, like five days a week for 3 weeks. And then you can start to cut back and then just periodically just maintain that. So it could be if someone's looking for, okay, do I push my hemoglobin hematocrit up? Do I get an EPO? And maybe even dropping iron, which is a good benefit. I saw a couple studies on that. I was like, wow, so if we could increase red cells without increasing iron, so now it's a way to deplete extra iron, which is one of the simple longevity or health things that people can do, is to keep a low ferritin.
And that's because iron is a pro-oxidant. Is that the theory, correct?
Iron is a pro-oxidant, and it binds in too high, it affects mitochondrial function as well. So making sure you don't have, and it's a guy thing. So if you're in the 100s, give blood every couple months. It's a good thing to do. And reducing iron stores as a pro-oxidant, and even epidemiologically, people who have given iron over their lives or given blood over their lives do have less risk of cancer or heart disease, and maybe even potentially a longer longevity. Although reducing heart disease and cancer themselves, as we said, maybe only buys you 5 or 6, 7 years, but that's in and of itself. But it's a simple thing to do. It's extra. And iron, you have to be like, the tweak with iron is you want to look at not just serum iron, you want to look at the serum iron to ferritin ratio, because ferritin is it's a reactive molecule. So it'll increase with inflammation in the body. So if I've done this, we talked about guys who are racing, we've done blood tests looking at inflammatory markers, sed rate, fibrinogen, homocysteine, ferritin. And if you check the blood of someone a week or so after they've done some heavy physical activity or in the middle of, a lot of times it's awful. So they're creating these inflammatory molecules. And we've seen people who have had just called immune stimulating therapies or injections of immune stimulating therapies. And you look at these inflammatory markers, they're sometimes very high. And it's happened a couple times over the past month. It was like, I've seen people like healthy, and I guess, okay, have you done some particular racing? Are you going to cycle, or have you had some injection? And it's one or the other 90% of the time that's triggered those inflammatory markers. And if you don't look for them, you can't see them. So it's looking at the white count can help, like a neutrophil lymphocyte ratio could be a sign of a viral versus a bacterial infection. So following these, just following particular markers are really helpful, because that helps you get back to finding your weak link or things that could be causing problems for people. So if you see bacterial, or someone has risks, like looking at oral bacteria, these are things that just are missed, but there's a strong link between imbalance in bacteria in the mouth and disease. And I was having a chat with my dentist, my dental hygienist, and I go like every 2 months, 2.5 months now, just to really keep them clean. And we were talking about it, and it's like, because I've always seen that the people who are old and healthy all have good teeth. So I don't know which came first, chicken or egg, but there's definitely lots of research now that coming out is bacterial imbalances causing periodontal disease also affect the body. And that, for some people, is a weak link. And if you have bad gums for whatever reason, you got to fix it, because that's going to wear you down. Yeah, it's just so many interesting little points. And it's like, the challenge is how to present this to someone so you don't overwhelm them, and to do it in a step-by-step, over time fashion. So for me, it's, if I get someone who wants to live a healthier, longer lifespan, they generally are already coming in generally healthy. So it's on the doctor, maybe a true doctor, and trying to not prevent, but instead of treating a particular, we'll call it imbalance, that's creating a symptom that someone wants to get better with quicker. You feel like crap, or in your case, hey, I want to get fit for this particular event. So there's a time they've set. For me, it's really, okay, you want to be healthy, but you want to be able, what do you want to do? And that's another question. It's like, what do you want to do? What are your goals? Do you want to keep doing kiteboarding for the next 20 years? Do you want to be able to continue riding? Where we are in Brevard, there are a lot of people who have retired up to the mountains, and these guys just ride the bikes every day. They love it. 50 miles a day. It's okay. There's benefits to that, and there's risks to that, but you love it. So how wouldn't you love to do this for the next 25 years? Yeah, like, it's their passion, it's their addiction, it's just what they love doing, getting out into nature. So how can you achieve that? But you don't have to achieve that next month. Take a year, take 2 years. That's okay. And just one step at a time to continue through. And that's requires a commitment to sticking through. And not everyone's willing or able to do that.
Yeah, definitely. And if we back up real quick as we get close to wrapping up here on talking about fasting and mTOR, How do you think about weighting that versus the risk of sarcopenia and muscle loss, which we know is a risk factor for longevity?
I think with full-time calorie restriction, you look at people who are living on 30% calories,
Oof.
they have
It
sarcopenia.
looked pretty horrible.
They look pretty horrible. If you even look at some of the Victor Longo studies, if you just do 5 days and then you come back, there's such this hormonal recovery period. And I've done a couple sort of fasting mimic diets where you go down to 500 or 600 calories for 5 days. And actually twice after that, like the second day of refeeding, I set like lifting records. I was like, how is that possible? Because you just get this massive hormonal surge. So if you're feeding regularly, people can maintain muscle on 16-8, right? A 16-8 intermittent fast. So doing a 5-day periodically really has no major effect. And one could argue it's even beneficial. And then rapamycin, part of sarcopenia is a cellular dysfunction. So there are studies that are actually showing that using rapamycin actually preserves muscle. The key is you want mTOR stimulation. You don't want to shut it off completely. You just need to just hit the gas for a shorter period of time. And that's what you do with rapamycin. You're not keeping it on all the time. You're pulsing it. And some of the indications are higher dose, taken less frequently. So 10 or 20 milligrams, some people are taking, just take it out to 2.5 weeks. So you hit a trough because there's 2 mTOR receptors. There's an mTOR1 and mTOR2. And mTOR2 is the one that they need to shut down for immune suppression. So you're actually trying to shut down innate immunity, which can be a good thing at times, but not for a longer period of time. So if you take the wrong dose and you haven't timed that, you might have some susceptibility to some immune issues, more likely to get an infection. But other than that, shouldn't happen if you're dosing correctly. And the thing about mTOR2 is you suppress it briefly and then it just regenerates. So it's an enzyme that needs to recover. If you don't give it that time to recover, you're never going to get that enzymatic complex that's needed. Yeah, so I'm waiting to see. We're working with a lot more people, but in sort of the forums and people I've talked to, and then there's it's starting to catch on. There's a national-wide telehealth group now that's offering rapamycin therapy to people through physicians all over the country. And the models still need to be refined. Just like anything, okay, rapamycin's good, take this. I'm just going to take 6 milligrams a week because that's what they said to do. You're probably okay with that. Just like the studies, we just don't know what your optimal dose is. And truly, you probably want to do some tracking, body weight, muscle mass, look for some key markers of health, and then at least ideally check a blood level 24 hours afterwards. And then maybe another time do a half-life, because there's the half-life of rapamycin is 60 to 80 hours. So you can start to break that down and say, okay, how low can I get it under a particular point where I know I've troughed out? And that's going to be different for each person, depending on how much they absorbed and how well they detoxify, just through their own nutritional status or their genetic status. And you can't really figure that out other than checking a level. And once you know that, you can say, okay, I could take X amount every 8 days, and that's going to keep me in a good balance. And that's not regularly done. Again, it just requires the physician to be educated enough, because a lot of times it's just a doc is saying, oh, I can help people with this. And it's just another piece to my practice. And they haven't really deep dived into this one particular area. Or a lot of people just are purchasing it internationally, just reading it on themselves. And some are really bright and some are just like, I'll just start, like the guy taking 80 supplements. I just want to take, there was a study on this and the study, and they just start taking stuff. And that has its challenges.
Oh, yeah. And I've often wondered with the longer fasts for, let's say, general populations, that I wonder how much of that is pushing their body to upregulate fat more as a fuel source, because generally it's very low calorie. Generally, you're trying to get insulin levels relatively low. We know that's going to push your body to use more fat as a fuel. They did a study years ago that compared overweight people to lean people. And in the overweight group, it took about 48 hours for them to have low enough insulin to see a big upregulation in fat use. Lean people, it was like 12 to 24 hours. So I've often wondered if maybe that's another side benefit to doing some of these longer fasts, where you're giving the body this huge stimulus now to try to use fat more as a fuel. So at the end of it, you might be more metabolically flexible at that point too.
Yeah, totally. And see, metabolic flexibility can go both ways. And that's where you can get to the point where you can't handle fats or you need carbohydrates all the time. And then you get people who can't handle carbohydrates very well.
Sure.
And that's one of the things after. It's interesting you mentioned that. And I haven't worn a CGM doing one of these. I haven't done one in a while, and I'm going to plan to do that next time. So I'm really curious to see what my glucose does during a 5-day fast. But people who have come off of those 5-day fasts, this is through one of the providers there are a few right now. So talking to one of their educators, it's like they've looked at people coming off of the 5-day fast, and they may start to eat too soon. And this person who was running like 70 for 5 days with their glucose level was at 180 for the next 3-4 days. They shut down insulin so much that it couldn't handle any carbohydrates at all. So you really need to be careful for some people as to how you're refeeding as well. So just coming off and then just flooding the body with more carbohydrates. Is that a problem? Probably not for a few days, but it's certainly an indication of loss of metabolic flexibility to handle carbohydrates as well. So just to be aware of that.
Yeah. And last question. So one of my little theories is that for longevity, once we've got a lot of good nutrition, doing exercise, doing sleep, that if we can target these homeostatic regulators within the body and build up capacity with them, that you'll be more functional as a human organism, and that hopefully that would translate to better longevity. So things like temperature, hot and cold exposure, pH changes, like we talked about, fuel usage, blood glucose, and then oxygen and carbon dioxide. What are your thoughts about that? As what systems would you, from a functional standpoint, try to target in terms of increasing longevity?
It's hard to not go with the food metabolic flexibility for the mass population, because that's such a big issue. But I'd say the other pieces to it is the parasympathetic sympathetic. So someone who really can't have that adaptation to be able to handle physiological or psychological stressors in a positive way, and we've lost that ability to modulate that. And that's huge, because that's another sort of key longevity pathway as well. So I'd say that's a really important one to address. And how do you use HRV to monitor that and to provide that feedback? Like I said, I'm curious to see where Hahnemann Health is going to come in with regard to using the polar strap and taking the elite HRV model and throwing in breathing and feedback periods to see what resonance breathing does. So that'll be interesting. They're using the right. I'm glad they're not using seismography. Obviously, you just can't track live with that, where you can do that with a polar more. Where the Leaf was good. I don't know if you've ever worn one of those. It was an EKG patch. Yeah, it was an EKG patch, but it was sort of a little bit awkward. And the app associated to that was very limited, but really it was set at a target where it would set your HRV target, and if it went too low, it kicked you into a resonant breathing pattern. Which was cool. It's actually, they use it for panic and anxiety disorders and depressive disorders. It's actually approved for insurance reimbursement for that purpose. But the Hahnemann, I supposedly, is going to have a much more broader, widely use for just developing that adaptation, which is something that I don't think exists in an easy way right now to do. And that's really powerful. So the other thing to mention,
the thought pattern with that you're trying to trigger you to do different breathing patterns during the day to increase parasympathetic tone. Is that kind of the overall theory?
That's the overall theory. So,
Got
and
it.
it's a trigger. It's a trigger to in essence, hey, when you're below a threshold, are you not breathing while you're emailing?
So an awareness component.
It's an awareness component, and perhaps it develops a behavioral classical conditioning. If you then
Sure.
develop this mind body, it's like, oh, okay, I need to stop. I need to get up, or maybe just take a walk and take some deep breaths. And now you've stopped that cycle from happening before it ever occurs, and it's a lot harder to get out of that issue. So that's a cool potential feature. And then there's one other thing to mention is going back to one of the first things I said is tracking, and have to be careful. There's a lot of, as I said, there's a lot of supplements out there that may or may not be worth their weight. And it's like, how can you track? And you can track objectively, subjectively, HRV, inflammatory markers. There are also chronological and biological age clocks that have making the market, epigenetic clocks as well. And there's challenges with them as well. Does that clock directly correlate to diseases and how you're doing? But I think the best one right now is when there's a lab called True Diagnostic, and they highlighted out, it's called a Dunedin pace. There was a study in New Zealand that is still going. It's been like 40 years now. It started people when they were young, and they're tracking all these biological factors, reaction time, blood levels, cognitive testing, and they're then doing programming. They're training the genetic clocks based on these people's sort of responses. So they can not only see changes in function, how that relates to age, but also to what's happening in the methylation sites on this clock. What's cool about this, it's not, and here's the difference, like you can get a biological age, and what I don't know what that means. It means theoretically, this is where your body is aging. There'll be organ clocks that actually can look at different systems as well. Those will be coming online, like your brain and your kidneys and your liver. But what the Dunedin pace does that nothing else is doing is it gives you a 3-month snapshot. So it's really more of a pace. So let's say you did everything wrong for 30 years, but now you're making changes. It will actually showing that rate of aging. So if you're aging 1 year to 1 year, you're chronologically based on the statistics and the groups, and it could vary a bit based on demographics, and they're working to improve that. But if it says 0.7, and you can keep it there, then theoretically you're aging 40% or 30% slower, and you've made a change. So now you've made a change and you can recheck it. And if you're keeping there, then you're doing the right thing. The slowest they've ever seen is like 0.66 or 0.65 aging per year. And the most they've seen is about 1.4, 1.5. So if you take someone 50 years old, and let's say theoretically, they're going to make it, let's say 80, 85. So if you're aging 0.7 per year, then that would have buy you, instead of 85, that'll get you to 100, right? At that same health span, versus if you're 1.4, that's only another 24 years. That's going to get you 74. So the difference between that aging for that person is 25 years. It's a quarter of your lifespan just by monitoring and making changes. This is like the 4th generation of these. So it's gotten to the point where now it can be used as a cool tool to, how am I doing? Not just, oh, I'm 62 and my biological age is 49. It's okay, whatever. More important was I did the pace, and it was like, it was 0.71. So that's pretty dang good. If I look age rate, I was like 98th or 99th percentile. So for my age, that's a good thing. So whatever I'm doing, I'm still losing.
Yeah.
We're still losing, but at least we're buying ourselves time. And maybe that's a final thought, is there's so much technology in this realm, and there's more and more money being put into this, billions and billions of dollars. There's a group in Saudi Arabia, actually not a group, Saudi Arabia themselves just committed $10 billion a year, to aging longevity research, and huge amounts of funds to this because they see the potential. Where we're going to be in the next 10 or 15 years, what's the singularity where we can say for every year of age, now we can start to move things the other way, is coming. So if we can we don't know how much we'll be able to regenerate. So the more we can take care of ourselves, we can, one, be around, but two, be in a better place where some of these things can make a bigger difference for ourselves. So interesting.
Yeah. And is that test from New Zealand, is that commercially available yet or not?
Yeah, it's licensed from actually Duke University by True Diagnostics. They're out of Lexington, Kentucky. Yeah.
Oh,
So
very cool.
I get anyone has questions. I don't know if you put in the show notes.
Yeah, I was going to ask, how can people get a hold of you? Give us a spiel where they can find you? What other stuff you've got available?
Yeah, so my day job is a nutrition brand, right? My day job, which I'm trying to move away from. I had a functional medicine practice for a bunch of years, and about 15 years ago, got into testosterone health in men and developed a nutritional product based on that. It was actually a pro-hormone product that, at the time, and that did really well. So I got focused. It was fun to formulate. So the past 10 to 15 years, I've had a few different brands, and it was fun. The whole supplement industry has changed so dramatically over the past even few years, just social media and influencers and the ability to truly educate in a core, meaningful way, and to try and provide products that are not overly, our markups maybe 3-to-1, majority it's like 8-to-1. It's like ridiculous. So it's hard to get that across. It's not my passion. My passion is longevity. I'm moving more into this space as what I do for myself, starting to share. I work with a small group of people as well. So the company is Pure Clean Performance. You can email me at rick@Pure Clean Performance. I don't have a longevity access set up. We do, through the website, offer labs and services, but I'd be happy to chat with people about their interest in health and longevity, and they need coaching or guidance. And at some point in the next probably 6 months to a year, either I'll be doing some consulting with one or two firms that has interest in my unique knowledge from functional to health and medicine, or just hang up a small shingle, work with maybe 20, 30 people who are really motivated. And because we can all learn from one another. I do this, you do that. And you say, hey, I did this, and it just speeds up our learning curve. And I wish that happened more, because you just have still so many diverse interests in the field trying to monetize something. And while there's certainly sharing in the community, it's small, but it's growing. And that's good and bad in all aspects of business and life.
Yeah, and my bias is, I think, especially in the near future and even starting now, there's going to be a bigger market for some people who are looking to do whatever they can to increase their life or health span. And I think there'll be a good market for people like yourselves and others who can look at the data and try to interpret what is best and most useful for that particular person based on research and experience and everything else as a holistic type model. I know some people are doing this more for the fitness area too. And I think in longevity, I think that's the next big area, right? So can you look at that individual as a whole person? What are they able to do? What is their time constraints? And figure out, okay, based on blood work, testing, functional analysis, whatever you want to do, here's like your top 10 things, and then provide the coaching on the back end of how to get them to do those things.
Yeah, it's coming. Peter Diamandis and Anthony Robin, they've started this fountain. Do you know how many people they have signed up on their waiting list? 25,000.
Yeah, okay. I believe it.
What want to guess per year, just as a starting, just enter the door, what your cost is?
Probably at least 100,000.
They're only 25,000. So they have $500,000 of like people waiting. Peter Attia charges $120,000 a year.
Yeah, I believe that.
It doesn't have to be that. And there's another one, Health Nucleus, out of San Diego, as well, as 30 to 35 grand a year. So I don't know if you get that. You'll get maybe some fancier care, but it doesn't need to be that expensive.
Yeah. And I think they're generally dealing with people who, not all of them, but people who want of the best. And I would imagine a lot of them spend a bunch of time sacrificing their health for financial gain. And now as they're older, I've realized, uh-oh, how do I try to reverse this? I have the money, so I'll just spend it. You know what I mean?
Right.
It's
And
kind
I
of a
know
niche
this person,
population.
so I'm going to make, right. So somewhere in between, there's something does cost time and labs and money, but there's something a little bit more affordable till we get some magic E5 or I don't know. We'll see. We'll see. They're doing gene therapies now as well. They just did one for cholesterol, a very particular enzyme for cholesterol. So one gene therapy shot and it'll take care of it for life.
Is that for hypercholesterolemia?
For a particular type of hypercholesterolemia. And there's a group called BioViva that's doing injections for clotho and telomerase and myostatin. So they have three. And they just did a study, small study, like 10 people for cognitive and pre-Alzheimer's and mild Alzheimer's. And the results were pretty impressive. So that's coming as well. So it's exciting. It's all from a bit of a science nutrition geek. It's what's the toy for the month, the new protocol. But the challenge is how to weed that out.
Yeah.
And I can't keep up, and it's what I do. Yeah. I have the experience. So how does someone who has another life that actually does other things? It's impossible.
Yeah. And they're going to be, like we said, bamboozled with all sorts of marketing pushing one particular thing, which again may be effective, may not, but the one thing probably isn't going to solve all of your issues. And so trying to figure out when to use particular things and in what order and where's the weak links and where's the leverage. And that's where I think coachings, physicians, that one-on-one relationship becomes super useful.
True. I can envision almost like a hybrid where because there's base education, there's foundational education that people can do, but then there's how do you start to tweak those based on each person's needs.
Yeah. Awesome. Yeah, so cool. Where's the best place people could get in touch with you then?
Yeah, Rick at Pure Clean Performance.
Okay.
Yeah, that works. And be happy to chat and dial in on what people's interests are. And I'm going to still stick with it's a spin-off my passion if there's a particular area that needs to be addressed. But ultimately, it's like you said, it needs to be a more holistic, comprehensive approach. And maybe not everything. There's some big pieces that someone may be overlooking. That's the important point, not to miss that.
Yeah. Awesome. Cool. Thank you so much for all your time today. We really appreciate it and for sharing so willingly on the podcast. That's awesome.
Yeah, I appreciate it. Great. It was a pleasure and hope to talk again soon.
Yeah. Thank you so much.
Okay. Thanks, Mike.
Thank you so much for listening to the podcast today. Big thanks to Dr. Rick Cohen for coming on the podcast and giving us all the great information and all of his time. Make sure to check out his links below, and you can also check out Pure Clean Performance there also. If you're interested in another way to increase true longevity, increase your body's ability to be more anti-fragile, resilient, and just generally much harder to kill, check out the Physiologic Flexibility Certification. Once you have the basics down of nutrition and exercise, what would be the next level of things you could implement to take your physiology even farther? This ranges from breath work to true high-intensity interval training, temperature changes, even the use of some other supplements, and about 20 plus hours more of information provided to you in a context so you'll understand why those areas are important, how do they fit into the big picture. Super hardcore dive into all the research on it, explained in a way that you will understand it. And then also 40 action items. This way you will understand exactly what it is you would need to do for either yourself or for your clients. And if you are a personal trainer, my bias is being able to do longevity work in addition to sets and reps and nutrition is going to be pretty much the new standard going forward. And how do you incorporate those things? What things would you need to do? And the nice part is a lot of them from the Physiologic Flexibility Certification, they don't take a ton of extra time since they're not usually incorporated into most clients' program. And most people just haven't done much work in those areas. The benefit then is the amount of time you would need to invest is on the smaller side then, which is great because it also makes it more practical. As I mentioned at the top of the show, the Physiologic Flexibility Certification opens again on Monday, September 5th, 2022. It'll be open for 1 week until September 12th, 2022. For all the information and much more, go to physiologicflexibility.com. If you're listening outside of that time period, still go there and you'll be able to get on the wait list, which will put you on the newsletter. You'll get all the latest and greatest information. And then I also have a couple cool bonus items that will go out only to people on the newsletter. So go to physiologicflexibility.com. Thank you so much to Dr. Rick Cohen for being on the podcast today. And if you enjoyed the show, please leave us a review, some stars, whatever stars you think are appropriate. We appreciate you listening. Thank you so much, and I will talk to you next week.
There's something wrong with this hearing aid.
Yeah, what's wrong?
I can't hear with it.
Oh, no wonder. It's too far away.